what we want to do is our goal is to try to rewrite 13 through 18 so that we simplify it down to log base 6 of 2 and log base 6 of 7. And then once we get it to that point, we are going to turn those into A's and B's. Now the one thing to note here is this 2 has an exponent. It has an exponent of 1, and this 7 has an exponent of 1. Okay? We come here to log base 6 of 32, and we're like, oh, you know what, 32, we can write that with a base of 2. That's log base 6 of 2 to the 5th. Now, the common mistake here is people want to say, like, oh, this is a to the 5th. But the issue with that is that a is log base 6 of 2 to the 1st, and this is not 2 to the 1st power. So I do not have a here yet. You have to use the power rule. So what happens is we use the power rule, and we have 5 log base 6 of 2, and notice now 2 is to the 1st power, so this becomes 5a. Okay, so not a to the 5th. Be very careful with that. For this one, we could subtract right away log base 6 of 56 minus log base 6 of 4, but it's actually easier here to divide first, because 56 divided by 4 is 14. And then 14, if we're taking a look, again, we're trying to get 2's and 7's. And so this is really just log base 6 of 2 times 7. But if you have one log of a product, you can expand that into multiple logs. So this becomes log base 6 of 2 plus log base 6 of 7. So this is our product rule. These two multiple logs, same base, you add them together, it's the same as the log of the product. Okay? Once we have this, here is our A, here is our B.
Oh, so A plus B.
Yep.
Wait.
So for this one, we have, again, we have a difference, or we have a quotient. This time we can't divide. All right, so this would be a good place to split it up. Anytime you have log of a quotient, we can write it as multiple logs of a difference. So 49 is going to be positive because 49 is in the numerator, and log base 6 of 8 is going to be negative because it's in the denominator. Okay, 49 is log base 6 of 7 squared, and then this is log base 6 of 2 cubed. Again, this is not a squared minus, or b squared minus a cubed, because we need to make sure we have the 2 and the 7 to the 1st power. So you have to use the power rule here. So we get 2 log base 6 of 7 minus 3 log base 6 of 2. And now we can say 2b minus 3a. And then for the last one, 28 is 4 times 7. So I can write log base 6 of 4 times 7, but that's log base 6 of 2 squared times 7. So now that I have my product, I can write it as the sum of 2 logs with the same base. So this becomes log base 6 of 2 squared plus log base 6 of 7. But we have to use the power rule here. This is 2 log base 6 of 2 plus log base 6 of 7. And now we can substitute. This is 2a plus b.